Um, our next presentation is about a hype topic at the moment in IT called Aiops. As it is with hypes, it mostly doesn't really meet expectations. So we have somebody here who has really done it for a client. We are sorry to say that our speaker from the client from Croatian Telecom couldn't be here at short notice. So Damir, who leads Cross AI, will do it on his own. And I'm pretty sure it will be impressing. It was impressing for me when I learned about it first time. So your stage.
Thank you. And thank you everybody for, first of all, being here. And in the next 20 minutes, I'm going to try to say a few words about our Aiops case study. But before that, I wanted to start with something that I really think is future-proof, because future-proof is the theme of the conference. And I was thinking, what is for me really a future-proof technology, or the thing that I really think is future-proof. And the first thing that I got is Legos, because Legos are here for more than 70 years. Everybody knows about it. Everybody played with it, maybe on their own, maybe with the kids. And I also really like Legos. And sometimes when you're playing with Legos or building something, you start with something small. For example, you want to build a house. And then piece by piece, you're building this house. And then you want to find blue Lego block that is somewhere here. But even though you know you have it, it's somewhere here, it's really hard to find it because you're looking for a certain type, certain color of the Lego. And this is the same story in an enterprise world that Johnny had. And this is Johnny. Johnny was in Croatian Telecom, but he's not a fake person. It's really, this is Johnny. And, and the haircut is pretty similar to this Lego. So this is why I choose, and the suit and everything. So Johnny is working for Croatian Telecom. Croatian Telecom is a leading telco in Croatia. It is part of the Deutsche Telekom group. And as most of the telcos, they're having the fixed line services, the mobile services, broadband internet, as well as the TV services. And all of those services needs to be up and running 24/7 for every single customer throughout the year. And Johnny's role in Croatian Telecom is officially Director of Operations and End-to-End Q&A. But what does that mean is basically that his job is primarily to use all the building blocks, the Lego blocks, the technologies, and all the teams he's managing, so networking, development teams, database teams, everything, and to have those services up and running 24/7. So I use my mobile phone, the internet, the TV all of the time. And whenever I use phone, it's really working. So I think that looking from the outside, Johnny's doing a pretty good job. But from the inside, his job sometimes looks like this. So it's a lot of problems, operational problems. So he needs to find what's not working. And the usual problem, like Monday story, is that part of the customers are using the HT mobile application and something is not working from them. So this means they cannot pay the bill, so the finance is angry, the CEO is angry, everybody's angry, and Johnny's job is to find why these 100 customers cannot pay the bill in the application. And Johnny was thinking about this because Johnny was really investing a lot in technology, so he has the legacy stuff, the modern stuff, all of the tools he bought. He also thought that it would be really smart that you have a lot of logs so I can track every single thing in the application. So only this simple application is generating 20 million logs daily, because from the outside, maybe it looks simple, but to get this number of how many megabytes I'm using, you need to use a lot of microservices, a lot of databases and stuff to calculate this one information. And then, sometimes it's pretty hard, even though you have the logs, to find what is not working. And then once you find what's not working, you need to find the appropriate team who can fix the problem and then start fixing the problem. So once they did it, second time they did it, and they thought about, okay, can we use that logs to write really good rules and monitor the system so it will tell us whether the system works or it doesn't work. So even though it was a good idea, it's pretty hard to write those rules, because when you start building one rule, second rule, you see that there are three things that you need to take care. First, you need to really define what the good rule is, because it's not easy to define a good rule. Second, you have a lot of services. So it's not only one application, because then you need to write rules for one database, for caching, for the backend part, the front-end part, whatever. And there's a lot of services you need to build rules. And the third thing is developers are the agile is now modern. They are updating applications every 7 days, every 12 days, adding new features, adding new bugs. So it's really, really hard to maintain all those rules manually. So Johnny asked, can you help me? And this was the problem. So we went back and we were thinking, and we defined we saw what is the problem, and we said, okay, we have the data. So, and Johnny wanted to create all those rules manually. Can we somehow train what is normal based on the historic data, learn the model, and then use this model in order to see whether the anomalies are in the real time comparing to this model? And okay, this sounds like a good idea, but how do we train this model? So what are the building blocks, how to train? So first, as I said, we have a lot of logs. So all those logs are coming into our system, and we need to somehow aggregate those logs. So we said, okay, let's take 30-second aggregates and try to make little building blocks that will somehow describe those logs in 30 seconds. So we are these in Cross little builders, and we said, okay, first let's see what is the average latency in that logs. Then we said, how many logs do we have? How many users do we have? Are there any errors for, again, what type of errors? 404 errors, 500 errors. So it's not the same errors every time. And also, what is part of the day? Sometimes it's okay to have 100 users. Sometimes it's not okay. Sometimes you're expecting 100,000 users to have online. And we're just, providing these measurements to the let's say, model. And then based on historic data, we are really learning what is the normal state for every single service. But we are not defining, how important these features are. Really, the algorithm, the model is doing this. And then in the real time, once we have what is normal for every service, for every user, for every database query, what we can do is we can look at this data, compare it to our model, and say, is this situation weird, or is it completely normal? And what is the output for the Johnny? So Johnny can now have one simple dashboard that he can look in Kibana, Grafana, wherever he wants to be. And then what he's really looking at only, these bar charts that are saying, okay, some problem started, or, we already, just started to process this, but we still didn't fix the problem, and then system, even went worse because a lot of services went to anomaly state. Then, developers were notified, they fixed the problem, and on the dashboard, Johnny can see now everything looks okay. So pretty simple, a lot of logs, a lot of data, a lot of complex system, but Johnny is now looking only at one dashboard that is saying, is it normal state or not state for complete system? And then if something is not okay, what we can do, because our system is automating, now we can have one service, but we can have 1,000 services. And if the service is not working properly, not looking good, we can, if you have granular data, and Johnny had, because he had a lot of logs, we can really go super granular and say, look, this service on this endpoint looks pretty weird. And we can also say why, because it has 42 errors and pretty high latency. So what can Johnny now do? I mean, he can really pinpoint the problem to 1, 2, maybe 5 services that are looking weird. and then even get the information about what is causing, and then still human in the loop, they will kind of use this data and then fix the problem, so we have a clean situation. But how do we do this? So how to build up this from the technical side, this AIOps platform? So first, we need to have the data, because without data, I mean, it will be pretty hard. But if we have the data, I mean, this can be application logs, APM logs, database logs, whatever you kind of have. It can be also business data, so marketing data that's kind of saying whether we will have a promotion on a push notification, because that will kind of impact that probably a lot of users will open the application. So it is normal that we see a peak. And then we are ingesting all this data, so a lot of data, transferring it, cleaning it, preparing all these things that I showed, and loading it to the feature store database, where we kind of calculate these things, these little builders that I showed on the previous slide. Once we have the features ready, we are using the AI service that's kind of calculating this anomaly score that is saying whether this looks normal or not normal. If it doesn't look normal, what we are generating is an alert. So Johnny is seeing this on a dashboard. And then if we are kind of seeing that this problem is kind of up for like 10 minutes or something, we can even notify the team. So we are notifying maybe team that is kind of responsible to that application, or the networking team, or whoever kind of is in charge for that part of the system. And this is one part of the equation. So doing the inference and generating in real time the anomalies. And the second part is we really need to train the system, because as I said, it's not one service. And if we are kind of doing this for each and every part of the system, we really need to automate. So it is not Johnny's job to start the jobs and do this manually. So we are kind of automating all these steps. So first, preparing the data, like maybe month of data, 2 months of data, cleaning it, creating features, and then training every single model. But not only training it once. So because new data is arriving, features are changing, bugs are added, and we need to retrain the models every 7 days periodically for every single service. And we are doing that. And we also want to have responsible AI. I mean, because a lot of now is talking about AI is not only black box and we don't understand. We also want to have a lineage, so we understand where the data is coming from, who trained the model, which version, which service. So we have the model repository, the dataset repository. So you have all the versions for every single service, kind of in a nice tool. So you can basically in one click maybe change version if the model is not working, or check on what data was it learned, whether it has any kind of problems, and so on. But the whole part of the training is kind of automatic. And with this, I mean, even though this was only one example, how we basically showcase that by leveraging data, we are helping the developers, the managers, the operational guys, but I mean, still we are not automatically fixing all the problems. So this is, just one tool that is kind of helping, not a silver bullet that is kind of clearing all the problems. But this is not the only problem that can be kind of taken by using, let's say, software 2.0 paradigm. So what do I mean? So some problems can be completely okay that if we have the data, if we have the rules, we can program those rules, and then we can have desired behavior. So for example, if I'm developing mobile application, I don't know, on the web, whatever the reason, it's completely okay to not use AI for every single problem. But for some problems, like for example, this AIOps, where we need to generate a lot of rules that are changing for every single service, or I don't know, detecting text in document, analyzing text, all those problems are pretty hard to write good rules. So for those problems, using the data and adding, what is the desired behavior, what is normal, what is not normal, and then letting the machine learning learn the rules, this is, usually a best approach for those types of problems. And we really thought about this, and here in CROZ, we really like to, build complex solutions, custom solutions for difficult problems. So we identified that using, this approach, data and, desired behavior, we can really kind of build building block by building block this platform that will kind of automate a lot of the steps for you. And then the only thing that we kind of need to find is first the good use case where this can be applied, and then really try to solve this problem in order to show the value and really enable some things that kind of were pretty hard to fix and pretty hard to kind of solve without this approach. So, and with that, I would kind of finish with just one question to really, really think whether machine learning can help in your business context, because even though AI is kind of hyped and a lot of people are talking about it, it's not a silver bullet, but we can find some problems that can really, really drastically change with this approach. That's it. Thank you. If you have any questions, I can answer now, or if you're kind of up for lunch, we can also do it on a lunch. So any questions? Yeah.
Can you elaborate how far Croatian Telecom now came with the solution?
Yeah, so this is now like in production. So this was not like a POC. I mean, it was POC, but now it's really in production, used by Croatian Telecom, analyzing anomalies. We started with that, and now it's already really in the real production, trying to help the customer solve the problems.
Is there any kind of learning curve? So how fast the new knowledge is collected and the alerts are better and better?
Yeah, so the first part of the system, it's when we designed it, we didn't have the label data. So we have only 20 million logs that are kind of just logs, not labeled, this is anomaly, this is not. So we use mostly the unsupervised way of really finding the statistical anomalies within the data when we kind of doing it. And with that, we don't have this feedback loop. But now, when we kind of have it and people are kind of using it, what we can do is, for example, when we have anomaly, we can put it on the dashboard, but we can also open, for example, a GitLab ticket or something like that. And then, people can kind of start doing and do the triage and tell us whether this was good alert or not, and then we can use this as a feedback loop in order to improve in the future. So in the version 2.0, it will be kind of incorporated in the algorithm. And thank you for the question. Okay, then again, thank you all, and if you will have any questions,